Yeah, so hello everyone and welcome back to our aptitude sessions. So yesterday or the previous session, we started with direction sense. We also started with the topic of Venn diagrams and we saw that there were three distinct types when it comes to Venn diagrams. Type 1, Type 2 and Type 3. Type 1 and 3 were covered in the previous session. So today we'll be covering it or closing the session today with Type 2 Venn diagrams. Yes. So yes, what exactly is type 2 Venn diagrams? So you have the same figure for different groups. Type 3 also has the same thing, same figure for different groups, but the relationship between the groups is being established. Here, the relationship between the elements and its respective groups are being established. So in
My
type
type
3,
2 is months, weeks, days. It's over, ma'am. This is also type 2 now, ma'am.
this is type 2. In the previous session, what we did was type 1 and type 3.
Oh, okay, ma'am. Sorry. Okay.
Yeah, no problem. So what happens is, yes, first we have a broad classification that is type 1 and 2 fall into one category where you have relationship between the elements and the groups. And type 3 is the second broad category where you have relationship between the groups. With the elements of the group, you're not dealing. You're dealing with the groups as a whole. That is type 3.
Okay.
Yeah, so type 2, again, you have same figure for different groups where you're dealing with different elements. Okay, elements within the groups. Yes. So one thing to, yeah, there are a few things you have to keep in mind. One is the OR symbol, also known as the union symbol. Okay. So yes, it is represented as a plain U, and to differentiate it with the universal set U have dashes on top. Okay. So remember, this is the capital U, this is the OR symbol U. Fine. This is something you have to keep in mind because most of your, aptitude exams are going to be online. If at least they're going to be CBT, which is computer-based test. So you may have to go to an exam center. A computer system is provided to you. You will log in with your credentials, probably your registration number or some particular ID or candidate ID or whatever. And there's a password that will be assigned as well. So with that, when you log in, your questions are going to come in this way itself, the typing way. Okay. So figure out the difference between universal set and OR symbol. All right. And yes, OR symbol or union is also logical addition. So you basically perform addition, okay? And when it comes to AND, which is known as, the intersection, it is multiplication. So here you have addition, and here it is multiplication, logical multiplication. Fine. Yes. So the next we have is universal set. So what we mean by universal set is the complete set comprising of the given groups as well as other elements which are not a part of the group as well. Okay. So universal set means the elements in the given set of groups as well as the elements which are outside that group. All of them put together will become universal set. It is represented as capital U, sometimes also as nu. All right, these are the two symbols which are used to represent universal set. The next is N, which is number of elements. So number of elements belonging to a particular group. Fine. So you have three groups here, A, B, and C, or three different set. So for example, N of A will tell the number of elements in A. Okay, so maybe 10, 20, 30, whatever that number is, maybe 5, 2, whatever. So how many ever number of elements belong to that particular set or that particular group, then you represent it using N. You could also represent using N of A union B, N of A intersection B, and so on. All right. Clear with number of elements?
Even you can identify like N of A, number
Yes.
of elements.
Yes. N of A
Okay.
can be used as N of A, N of B, N of C,
N
N of
of
U. Okay, N of U
Okay.
or mu. Even the universal set you can take the number of elements. At the same time, you can even take union, intersection, difference, symmetric difference, and so on. All of them. Right. So the next is
Okay.
complement, A complement or any complement for that matter, also known as A dash, sometimes also represented as A bar. So there will be a dash on top, which is known as A bar. Okay, this simply means the complement or the reverse. So what it means is all those elements which are not part of A. So if you take A complement, this is A, this entire thing is part of A. So everything which is not inside the circle, that includes this. Also the universal set. So all those which are not a part of A, all of these will come under A complement. Even this portion, this full box will come under A complement, except for the circle called A, the complete circle called A. Fine. Have you guys understood what is a complement?
Yes, yes, ma'am.
Okay. So fine. Then there is something called as null set. Okay, it can be a set which is non-existent. It can be a set which is existing as well. It can be in either ways, but it means that n of any null set is always zero. It has no elements. Even if that set exists, it has no elements inside that set. Okay, so if there is any set which has no elements in it, then it is called as null set. All right, for example, we have three set over here, A, B, and C. You have three groups. Let's say D. I'm not giving D in the diagram, but n of D here is nothing but zero. So D is nothing but a null set. Fine. So
Yes, ma'am.
yes, it could either be an existing set, it could either be a non-existing set. Let's say we had D over here. Okay, so this this is 3, 4, 5, 6, 7. Yeah. So D completely has no elements in it at all. So the set D exists, but there are no elements. So in that case also, n of D here is also 0, which implies D is a null set. Clear, the set is empty. Either it is non-existent, or even if it is existing, there are no elements in that set. So no doubts? Okay. So yes, if these basics are clear, then we have few formulae to look at. So one is, yeah, any given nothing but it's the difference of u minus a complement. So let's say if it was the set B, B is equal to u minus B complement. So if you have to take this A, it is nothing but U. Okay, all those things which are a part of this universal set, but not a part of A complement. What is A complement? This. So everything which is just not part of A. So what is A complement? Things which are not part of A, that is A complement. Correct. So this red line indicates A complement. So U minus A complement. So everything that is a part of U, but not a part of A complement. So is this A part of U? Yes. Is it a part of A complement? No. So you are landing up with A as your answer again. So that's exactly what we mean. If a particular value of a particular set is not given to you and you want to find it out, this is one formula that you can use to find it. Yes. So yeah, the next formula, that is A union B. The most standard and the most common or most popular formula among the set theory, that is A union B, which is A plus B minus A intersection B. Yes. So coming to A plus B. So what do they mean? First, you're taking the entire set A. So what is your set A? So this entire thing is your set A. And coming to set B. So what is your set B? This one. So if you notice, this intersection is coming twice. It's marked with both green lines and blue lines. Am I correct? So it's which means while you're adding it, you're adding the intersection two times. Because of this only, we are using something called as minus A intersection B. We are subtracting that A intersection B because you are adding it two times, you're subtracting it by once. So you're left with adding only one time. Is this concept clear or you still have doubts? You're still
Can you
doubtful?
repeat? Yeah.
Okay. So fine. This time you guys tell me what exactly is set A, from where to where. This is set A. Okay, so this is also set A. Right. So this much you people agree is set A, correct?
Yes.
So if you are adding set A, you're adding all of these elements. Also, one time you're adding all the elements from the intersection also. Do you agree with me in this?
Yes, ma'am.
Yes. So fine. So set A is clear. So coming to set B. So is this set B? Is this circle B? Does it belong to the
Yes.
circle? Yeah, it belongs to circle B, correct. But at the same time, since it is belonging to circle B, we are adding the circle B. This intersection we are adding with B also. You agree with me?
Yes, ma'am.
We are adding these, what is that? The intersection elements. Once with A also we are adding. Once with B also we are adding. You agree with that?
Yes, ma'am.
Because blue lines are coming on the intersection. Green lines are also coming on the intersection. So when green lines came, you added that intersection with A. When blue lines came, you added that intersection with B. Correct? Yeah. So what did you do? This intersection, you took it twice. One from set A, one from set B. Okay. Yeah. So it is two times. What you're doing is actually two times of A intersection B you are adding. So what should we do? But should your actual answer result in two times of intersection? No, it should result only in one time of intersection. A union B is this entire thing. So yeah, this is A union B. The yellow lines are A union B, correct?
Yes.
Intersection come one time or two times?
Two times. Like one time, ma'am, when we are taking complete A union B, it comes one time.
Yes, it comes one time, but while you're taking the formula, it's coming two times. Do you agree with me? Since you're adding A and you're adding B.
Yes, ma'am. Yes, ma'am.
Because of that,
Adding A.
yes, because of that, we are subtracting it by A intersection B once. So this minus one time of A intersection B, so it's nothing but one into A intersection of B, like how you have two into A intersection B, minus one time of A intersection B. So since the variable term is the same, 2 minus 1, we will get one time of A intersection B. So A union B requires only one time of intersection. But while you're taking this formula, you're having two times you're calculating the intersection. So for that, we are subtracting it by one time of intersection. Got it? Okay. A union B, the intersection has to come only for one time. Agreed? Shilpa?
Yes, ma'am. Yeah, for A union B, it's coming in one time.
Correct. But when you're taking the formula, just now I told you, with A
Oh,
you're taking once,
okay.
with B you're taking
Yes.
one. Correct? No?
Yes,
So now
ma'am.
since you're taking one from here, one from here,
Intersection.
it is becoming two times of intersection.
Yes, ma'am. Yes, ma'am.
But as what should your actual answer be? One time of intersection. So if there are two, subtract it by one. So 2 minus 1 is 1.
Okay.
Okay, ma'am.
Yes. So that is how this formula has come in. That is why we are using this minus A
Ma'am,
intersection.
actually, I understand about A union B and A plus B minus A intersection B. I understand about that. After that, subtract it with 2 minus 1. I didn't get it, ma'am.
Okay. So see, A intersection B, you got 2 times of A intersection B, correct?
Yes.
Yes, ma'am.
Yes. So if you have, for example, 2x, okay, and I tell you to subtract
Okay.
minus 1x, what will you land up in? What is your answer?
1x.
1x. Yeah.
Why 1x?
Minus 1x is 1x.
No, why exactly did you calculate it as 1x? Or how did you calculate it as 1x?
We omitted one, ma'am, by minus.
See, that's what. See, this x and x, the variable terms are common here. 2 and 1 are not variables, they are constant value. Correct. X is a
Yes,
variable
ma'am.
value. I can give any value to it. I can tell x is 10. In a different example, I can tell x is 5. In some other example, I will tell x is 200. So x is a variable term, but this variable term is same. So for one particular problem or one particular example, if I tell x is 10, throughout that example, that x has to remain 10 only. X cannot change in between to 20, 100 and all. Correct? So in the same example, since I've taken x, here also it is x. Okay, both the places it is x. Since the variables are same, the constants or the numerical values of it, you can do the operation, mathematical operation. So
Yes.
that is how you took 2 minus 1, 1 multiplied by the variable, because in both the cases it was the variable x. So you took 1x. So now instead of x, you put A intersection B and you substitute. Just put A intersection B as your x.
Okay.
So that's exactly what I told. So 2 times of A intersection B, that is 2x, minus 1 time of A intersection B, which is 1x, will give you 1 time
We
of A
can.
intersection B, which is 1x.
Okay, ma'am. I get it, ma'am.
Yes. So that is what we do. Since you have A plus B, A plus B is already giving you 2x, that is 2 times of A intersection B. So you're subtracting by 1 time of A intersection B, so you're getting the answer A union B. Yes. So yeah, if this is clear, we'll move to the next part of it. A union B can also be written as A minus B plus B minus A plus A intersection B. So what do we mean by A minus B? That is A difference B. So what is difference? All that belongs to the first group but should not belong to the second group. So yes, here does this belong to the A but does not belong to B? Condition pass or fail? Pass. This much does it belong to A? Condition pass or fail? It belongs to A but it has not reached B. Why? Because this is B. This part, I should not cross this red boundary here. Okay, so yeah, this much is A difference B, which means all that elements which belong to A but should never be a part of B. Got it? So yes, A difference B is done. Similarly, B difference of A. B difference of A is just the reverse of what you did. It should belong to B but should not belong to A. So let me use a different color for this so you will understand. Yeah. So A, in when it comes to B, this entire thing is B. In this entire B, this much portion belongs to A as well. It of course belongs to B, but it also belongs to A, correct? Now, since there is a small chance of this belonging to A, we will not use it. For example, when it comes to A, this green portion is also part of A. But why didn't we take it? Because it is a part of B in the first term. Similarly, this red mark also is a part of B only, but we are not taking it. Why? Because it should belong to B but should not belong to A. Okay. So only this green portion is B difference A. all that which belongs to B but does not belong to A. Or at any cost, for any reason, anything that belongs to A should not come. Got it?
Yes, ma'am.
Are you guys clear till here, or do you have doubts? Do you want me to break it down?
No, ma'am.
Okay. So when you need A union B, you have this A, you have this B. But did you calculate the intersection?
No, ma'am. We
Correct.
should add it.
Yes, we should add. So that is why we have taken A intersection B.
Yeah.
So that way it will make union. You will get the answer for A union B, this entire thing. Since you're counting the intersection now, this entire thing will give you A union B. Got it?
Yes,
Yes,
ma'am.
ma'am.
Okay, so fine. The second formula is done. Yeah. Next one, A intersection B. So you need A intersection B. Again, you're taking the set A. But is it A difference B? No, it is fully or wholly the set A. So you're taking this entire set A. Next, plus B. So you're adding B. So you're taking this entire set B because it is given only as B. It is not given B difference A. It's given only B. So full set B also you will take. But what should be your final answer, or what are we calculating? Only the intersection. But by adding A and B, what did we get? The union of it. So add A, add B, remove the union. That is elements which are belonging to both the groups. If you remove that, yes. So where is it? Yes. So this entire yellow line is union. Correct. So red minus yellow is just giving you the intersection. So how that works, let me show you. Yeah. So yes, this is your A plus B. And you have here, yes, A union B. So in both the cases, the intersection is there. So if you minus the union of it, you will just get the intersection. Or in simple words, the previous A union B formula, you're all convinced, correct? So I'll start with that. So A union B, take only this first half. Okay, so the sign here is negative. If it has to come to the other side of the equation, it will become positive. Agreed with me?
Yes, ma'am.
Yes, ma'am.
Yeah. So what do you get? A union B plus A intersection B is equal to A plus B.
Yes, ma'am.
Yes. So now, what do you need? You need only this A intersection B. So what will you do? Send this A union B term this side. When you send it to the other side of the,
Minus A.
yes, it becomes minus. So you will get A intersection B is equals to A plus B minus A
A.
union B.
A.
Okay, so yeah, you got this formula now?
Minus A.
Yes,
Yes,
ma'am.
Okay, fine. The next one, that is A union B, the whole complement. So what is A union B? This much. Yes. So this represents A union B. And what exactly is, the complement of it? Everything else which is not a part of A union B. Yeah. Yeah. So all of this will become A union B, the whole complement. Agreed with me? The
Yes,
green
ma'am.
is nothing but A union B, the whole complement. So since you have A union B, the whole complement, so you can, yes, you can use U one formula is to directly use this. So instead of A, if you substitute A union B, you get U minus A union. So yeah, you need the complement. Okay. So you will have A union B, the whole complement is nothing but U minus A union B. This is one way of finding out what I did just now. Yes. Another way is, okay, so you have U, that is universal set, plus A intersection B. Fine. So let me erase this. Yes. You have the universal set, this entire rectangle, okay? And then you have this A intersection B, this part. Fine. So do you think this, A intersection B is already a part of this universal set?
Yes, ma'am.
Yes. So which means with universal set also you are adding it. With this also you are adding it. So you're going to subtract A and B value. Minus A minus B. Fine. Keep that in mind. So that this is one thing which I am not sure if I'll be able to prove it here, but let's give it a try. So you have A intersection B, and what was your universal set? The entire thing. This entirely was your universal set. You agree with me?
Yes, ma'am.
Yes. So among this, you've taken the intersection and you've taken this universal set. But what do you want? You need A union B, the whole complement. So what is referring to the complement value here? This portion. Uh-oh. Yeah. So everything that is out of A union B. Okay, so this entire purple portion is what exactly we refer to as A union B, the whole complement. Fine.
Yes, ma'am.
Yes. So you've taken the intersection, but what about this one? That is A and B. A and B are also part of, A union B, but that should not come. That should not come because the purple line indicates A, this one, complement. A union B, the whole complement. Okay, so purple line indicates this. Correct, the complement, which means this A union B should not come. But your yellow line indicates the universal set. So as per universal set, you've taken both A and B, correct?
Yes, ma'am.
Shilpa, are you convinced or you're still doubtful?
Ma'am, I'm getting up to like what you're telling. I'm not getting why we should minus A and B.
Okay. So what does the yellow line in the picture represent?
Universal set.
Correct. So in
Universal set.
universal set, you have considered A and B as well.
Yes, ma'am.
But
A
what
and B is also in universal set.
correct. But what are you looking for or what is your answer going to be? Things which are not there in A and B. What is meant by complement, which is not a part of A and B,
Yes.
right? So yes, A union
Yes,
B,
not
yeah, but you have taken the universal set, so you have already considered A and B, correct? So what should you do? You should
yes, ma'am.
remove that.
In universal set, A and B is also there,
So
so
you
we
should
should
remove it.
minus it.
Yeah, so that is why minus A minus B.
Remove that. Okay, ma'am.
Okay, so clear with this formula? The fourth one?
Yes, ma'am.
Okay. So fine, that is done. So the next one, universal set is equals to A plus B minus A intersection B plus A union B, the whole complement. So yes, this is a universal set. You have A, that is
Yes.
this entire set. You also have B, which is this entire set. So again, same logic as A union B. You've added A, you've added B. Intersection is added 2 times.
Yeah, where
But
minus it.
set, it's there only once. So you're subtracting by A intersection B. Okay, so this much is done. But what about these, green elements which are outside the, A union? these elements. What about them? They are
They
called
are
as
complete.
the whole complement. Just now in the
Yeah,
previous
it's
formula, I
part
told they are A union B the whole complement. So you are adding that as well. Yes. So the next formula. So A difference B. So that is all those which are a part of A, but for any reason they should not be a part of B. That is this particular portion. Okay, so yes, this portion is of course a part of A as well, but it is also a part of B. Okay, so since B is also involved here, we will not be considering. That is the whole, thing about, or that is the meaning of A difference B. Fine, so this only this, sorry for that, only this red mark will be considered as A difference B. Fine.
Yes, ma'am.
Yes. So this A difference B is given by A intersection B the whole complement. How? Let us see. So what do you have A intersection B? This one. Yes. So A intersection B is this, but A intersection B complement. So let's keep A intersection aside. Okay, let's take only B complement for now. So what is meant by B complement? All that which does not belong to B. So yes, when you say B complement, even this will be considered. Got it?
yes, ma'am.
This portion is also considered. But is it a part of A difference B? Not completely. This portion is not a part of A difference B. For that, we will subtract with A intersection. So if you minus this A intersection, that means you will not consider that A intersection. So you will remove that intersection. So did you land up with where we started as A difference B? The green lines have come to the same place as A difference B.
Yes.
Yeah, so that is exactly the formula A difference B. Fine. It is also the same when it is A minus A intersection B. So you have, yeah, that's the same thing we did just now. Okay. So let's say you have the second part of it, which is A intersection B, that is this. And A minus, which means it should belong to A but should not belong to this second part. It should be a part of A, but it should not be a part of this green shaded area. So what is it? So what are you left or what is remaining with us? Only this portion.
Yeah.
It's all part of A but should not be a part of that green mark. Again, did the red lines come up to A difference B? Part of A but not at all, but nothing of B is there. It's come to the same shaded area as A difference B. So that is the second, formula that you can use for it. It is also equal to A union B if and only if A intersection B is 0. Oh, sorry. Yeah. It is equal to A if and only if A intersection B is 0. How? I will tell you. So yes, you have this formula A minus A intersection B. Let us say this A value is given as 10. Okay, and this A intersection B is completely 0. Fine, so A intersection B is 0. So what exactly will be the value of, A difference B? Only this. Because intersection has 0, A value is 10. This value, this red shaded area is also 10. Do you agree with me till here?
Yes, ma'am.
I didn't get it, ma'am.
Okay. So the given set A
What
is
will be that universal set will be also 10 value of the A value of A is 10. But what about you outside places also like universal set is also 10 how?
No, we are not considering universal set. We are only considering this red shaded portion